Alright, so recording has started, and I'm going to wait a few minutes for the rest of the class. This is the first day, and some people are just trying to figure things out. We'll start up in about 11:37. I'll start doing the real class. Where do we buy the book? Alright. Is the bookstore still available online? Does anybody know about that? Certainly you can buy the textbook online. There are those who probably need to, yes, okay. Kylie said she saw a post on Canvas. So if you need to buy it through the bookstore for financial aid reasons, you can do that online. Okay, under 30 bucks, renting it. And I made that, I sent out that email, okay, that you can get a 14-day free trial. So even if you're having a hard time coming up with 30 bucks right away, you can get 14 days free by registering in my math lab and then just letting that go at the end of 14 days. So I'd really like you to do that if you are not getting the book right away, so because you can't afford to fall behind. I'm going to give you an assignment today, and you're going to need to have it done tomorrow, and so you're going to need to get access to some version of the book immediately. And alright, we shall get started now. And the first thing I want to check is let me know if you do not have a mic. So type in no mic if the computer you're working on does not have a microphone. Anybody in that situation? Like you're on a desktop and there's no camera that has a mic there. It looks like everybody has a microphone. Alright, that's cool. Then let me describe what you're getting into this semester with Calculus 1. So a real brief overview about what is calculus and why did it come about and what's it doing. And I'm going to go into this thing called OneNotes. And by the way, all the notes that I take in this, you'll have access to. So there's in Canvas, there's one of the announcements about OneNotes is how you can get access to this. So I am going to put this in draw mode, and if we have a situation like this. Alright, so I'm just getting used to this. It's called a Wacom tablet. And I'll get better at this, hopefully, as the semester goes along. Alright, but now, if you have a situation where here is your time, and this is your distance. And at time 0, you are going to start, let's say, in your garage, 0 miles from home. And you start pulling away from your house, you're going on a straight road, and you're going away from your house, and then you get faster, and you go, and then you slow down, and then you stop for a little while. Now while you're stopped, your distance from home stays the same. And then you start heading back towards home. Oops. And you wind up going very fast towards home. And then you slow down, and so on. And eventually you get back home. Alright, at any point in this picture of time and distance, and suppose this time was in hours, and the distance is in miles. At any point in this traveling trip, you could get your speed. The speed, how fast you were going, turns out to be your slope. If you're right up here at the top, you see we weren't getting any more distance from home during this whole portion right here. You were stopped from here to here. And the slope is how fast you were going. When I was right here, I was going pretty fast. Okay. And now, how fast was I going at any particular point? At any particular point here, you can get how fast you were going by looking at what we call the slope of the tangent line. The line that just nicks the curve at that point. Now that is a tangent line, but we're trying to find the slope of it, and that's the slope of that line then is how fast you're going at that instant. Now, you might think, well, that's, sure, that sounds like a reasonable problem in math. To find an instantaneous slope, though, that's the essence of calculus. It's the primary concept in all of calculus, is to get the slope, the instantaneous slope at a single point. And it turns out that that is the key that unlocks a huge amount of mathematics. When this was discovered in, I think it was, I forget exactly the time frame. Late 1400s, 1500s, I think. Isaac Newton. And there was two guys that discovered it simultaneously. Well, Isaac Newton actually had discovered calculus first, but he hadn't published it. And while he hadn't published it, he was kind of a recluse, and he stayed by himself in his home. Particularly, there was one time where he was sent home from the university because, kind of similar to COVID times, except it was war times, and it wasn't safe to be at, I think it was Oxford. So they sent all the students home. And while he was at home, let me go back to this. While Isaac Newton was at home, he was working on one of the big problems of its time was figuring out why the planets moved the way they moved around the sun. When they could look in the sky and see the motion of planets and how Earth is going around the sun, there was so much that was unexplained. It appeared that some planets did little mini backtracking in little circles and so on, and they had no idea why this was happening. And Newton, in order to figure it out, needed a new math to do it, and he created calculus that could solve the problem and explain why the planets moved the way they moved. And he figured out much of this during this time of war when he was sent home from university. And then years later, when he had become a respected mathematician, this guy named Hooke came to him and said, there's a group of us that are trying to solve this problem, why the planets move the way they move. And we're stuck, and we can't get anywhere. And Newton said, oh, I've already figured that out. And then Newton showed him I had to invent this new math in order to figure it out. And Hooke said to him, oh my God, you have to publish it. And he had this for a number of years. So Newton started to publish it. And meanwhile, while he was publishing, getting it published, this other guy who had developed it independently published his work on calculus. And the other dude's name is escaping me right at the moment. Let me look it up. I think I have it somewhere in my notes over here. Alright, it'll come back to me a little bit later on. I don't see it. So anyway, the other guy was German. He came up with, and Isaac Newton was in Great Britain. And Isaac Newton strongly suspected the other guy had cheated and somehow gotten a hold of his notes. And because Isaac Newton had discovered it before the other one, but the other one
Professor?
Yes.
I believe it was Gottfried Leibniz.
Yes, that's it. Thank you very much. Leibniz.
Yeah, right.
Or Leibniz. And so, thank you very much. Is that Neil?
Sure.
Thank you.
Oh, certainly.
So, it turned out that Leibniz wound up really regretting and the historical record shows that he had developed it independently of Newton. But he regretted that because he got so much tremendous flack about that. Newton eventually became he had the highest seat in the whole world of academia, like the chair of the science department at the most prestigious school, and it was, he was kind of like the king figure in all of math and science. And he, at that point later in his career, he then decided to form a committee to look into who had really developed calculus. Was it himself or Leibniz? And he appointed himself as chair of the committee. And as we know now, the assumptions that you make when you look into something make a huge difference. And they might not have known that then. And he wound up assuming what he wanted to prove, which is what we try not to do in mathematics, and wound up coming to the conclusion that Leibniz had cheated, and when in fact he had not. And so now this has to do, though, with, we're back here with that picture that I drew. And where did that picture go? Yeah. All right. I lost my picture. I'm still getting used to this stuff. And I have a backup system of my old board if I run into too many problems with this. All right. So what's this all have to do, though, with this quick? Let me just, come up with. Here we go. If we're trying to find an instantaneous slope, if we're finding an instantaneous slope, that is the essence of the relationship between these two variables. The time on the one hand, over here, and then the distance on the other. How these two things relate to one another, and how any variable changes with respect to time. How this variable up here changes with respect to this variable in time. The essence of the relationship has to do with the slope of it. And in fact, when this got unlocked, there became a world of information that started to be accessible, which is how anything can change with respect to time. And we have all kinds of things that change with respect to time. And in this calculus class, you'll get the basic introduction to the big concepts in calculus. We'll go over, and the main concept of calculus is the instantaneous slope. And we'll spend in Calculus 1 the majority of our time working with the instantaneous slope, which we'll give a new name. We'll call that the derivative. And then towards the end of the semester, we'll work on the inverse of that, and it'll be called the integral. And those two concepts, the derivative and the integral, are the two main concepts throughout all Calculus 1, 2, and 3. Now, this idea, though, of how something changes in time, and the essence of that is the slope, the relationship between the variable and time itself. And it could be, one of the variables doesn't have to be time, it could be something else, but very often it is time, allows us to wind up to create functions for how something changes over time. And we'll give you a brief introduction to this, which is called a differential equation. And differential equations are equations that contain derivatives, which has this information about how things change over time. And one of my hobbies is I play board games. And both of my boys, I have two boys, and they're now 17 and 19 years old. And one time I when they were quite young, like 10 years old or less, I'd taken them to a board game gathering, and they loved playing board games with me. And we were at this one place, and we saw this apparatus. It was a big sand pit with a big arm that went up and a camera and a light that was shining down from above it. And as we were looking at it, it had something about it that it was simulating firefighting. And I kind of intuited what it must be about, and I was trying to tell the boys that this is modeling how things change over time, and at the heart of that is going to be differential equations. And as I was saying that, this guy overheard me, and he said, "I'm one of the people who created this thing." And he said, "And you're exactly right. It's differential equations that's behind all of this." And then he turned on the device and showed us how it worked. And he said, "All right, let's move the sand." And he pushed the sand into hills and stuff. And he said, they used to have to train firefighters by actually lighting fires out in the wilderness, and then have them go create a fire break, and then see if the fire, jumped over this, kind of fire break kind of road that they had built up, and so on. He says, nowadays, we can just simulate all this. And after setting up the terrain, and then he used his finger to, twisted his finger around and made at a certain spot so that the wind was going in a certain direction, and he set the amount of wind. And then he took out his lighter and put it over the sand, and then the picture of a flame bursting from that point was coming out, and then he was showing, so this is how the fire is spreading. And then he, draws like lines over here that here's a fire break, and let's see how, does the fire jump over the fire break and all this kind of stuff. And to model how the fire would change over time, at its heart was these differential equations. And in this class, I think it's one of the most exciting topics, calculus. You're going to get tools to actually do realistic modeling situations eventually. If you've been in algebra classes where you felt like, oh my gosh, they give us application problems, but none of them are realistic. They're all kind of contrived. One train heads east at 30 miles an hour, the other goes west at 20 miles an hour. When are they going to meet? And when am I ever going to need this? And why is it so not set in a very meaningful context? One of the explanations for it, actually those problems can be set in more meaningful contexts, but one of the explanations why they typically are not is you can't do all that much very significant modeling without calculus. So they wind up having to take very simplified situations to be able to solve it with just simple algebra. When you're modeling real-world situations, real world is complex, and you need a more complicated tool. And we're going to learn that here in calculus. And the scope of what we're learning and how it can apply is just giant and huge. In fact, there's even, like if you go into mathematics as a career, and you say, I'm going to be a math major, you're fundamentally going to make two choices. One of two areas you go into, either applied math or theoretical mathematics. And if you go into applied math, basically what you're studying is differential equations, because that's how we apply math to the world. And you become very good at working with the differential equations. Now let me check quickly over here. I want to run through if I'm seeing some more people who are missing. I'm still seeing the same folks. Alright. Alright, in Discord now, I'm gonna tell you how we're going to be using this software. One of the ways we'll be using it. You see over on the far left here, I have group 1 through group 6. And we have everybody seems to have a microphone, and right now everybody is in the text channel that's the general text channel. You should be there. If you click on the general text channel, you're seeing, Kylie's last post I did as well. Now, if you click on one of these group ones, like group 1, you're in a different text channel. You can always come back to the general text channel by clicking on it back over here. All right. So while this class is going on, you're going to be going back and forth. You're going to be assigned a specific group with a small number of group members. And inside your group, I'm going to have you do a small activity with your group members now, so you kind of figure out who your group members are. Also, if you have a preference, like you have a friend in this class and you really want to be in the same group, you can let me know right now. Otherwise, I've kind of just have randomly assigned people into groups. And let me show you what groups you're in. So on this screen, you should see your name, and this is just in alphabetical order. You're in one of the 6 groups. Alright, so once you identify what group you are in, I want you to enter that text channel, and hopefully your username is your own name, but if it's not, identify yourselves over there, and so everybody just go ahead and get into your group and type in your name over there, and I'm going to check to make sure that each group has at least 2 people in it. It's not good if there's somebody in their own group. Alright, so go ahead and do that right now, and then I'll describe more how we're going to use these groups. Let me give just a little more time. Everybody has gone in, typed something into your group, and I think we have enough people that are missing that we got a few groups. Just 1 people. Alright, group 5 is okay. It's got more than 1. Group 4 is okay. Group 3 is okay. Group 2 is okay. Group 1, there's nobody, maybe the Gerardo. And then group 6. There's 2. Alright, Gerardo. Abandon group 1 you go into group 6. Okay? Alright, now we've got at least 2 people in each group. Alright, so what I want you to do then is on the other groups that you are not a member of. So here's group 1. Nobody's going to be a member of that one. You right click on it and then you mute the channel until I turn it back on. And everybody do that with all of the other groups except the group that you're in. You don't want to mute the group that you're in. You want to mute the other groups 1 through 6. You don't want to mute the general channel. But mute the other groups, but not the one that you are in. This way you'll be able to get notifications. A little notification will pop up when somebody in your group has entered something in while class is going on. But you won't be bothered by notifications when members in other groups are notifying, texting something to each other. Alright, so let me give you 30 seconds here to mute the other groups that you're not in. Alright, and now a couple quick activities inside your group. You'll be working with these group members throughout the semester. I'm going to have each of the group each group assign a leader to the group. And that leader is going to have a specific responsibility. When class is going on, when somebody has a question, and I tend to make mistakes. I'll make little mistakes when I'm doing the math, or something will come up where something went too fast and you got lost, and there'll be various things that will happen. Or you'll have a question, a very specific question. The group leader will be keeping track of what's happening in their group. And when somebody types in something like, "I'm lost," if the group leader agrees with that, and the group leader is lost themselves, or the group leader sees that 2 people have entered, "I'm lost," then the group leader will have the responsibility to interrupt me verbally with the microphone and say, "Robert, there is a question." And somebody's lost, or whatever the issue is, and then we'll be working through that stuff. So the first thing, though, before you pick out who's going to be your group leader, is I'm going to have you do just a couple activities to introduce yourselves. First activity is within your group text channel, just type in why you are a student at SFCC. Well, why aren't you somewhere else? Why SFCC, Santa Fe Community College? And then this will be real brief, quick statement, and then you can comment or reflect on each other's responses real quickly. And nobody's there. And there's something else that's kind of novel about this online experience here. Is if we were face-to-face, there's certain advantages, but also disadvantages. when you're face to face and I put you in a small group and I have you introduce yourself, one thing is that only one person talks at a time. Here we have an efficiency where everybody can be kind of typing at the same time. One of the drawbacks, though, or limitations here, is we don't get the kind of interaction that you get when you talk and you see somebody's really listening to you. You don't know here if somebody's really reading your stuff. The only way you're going to get that feedback is if somebody kind of replies back about that. So that's kind of encouraged is, hey, why you're here, that's, has some similarity or difference to why I'm here and so on. Another thing I wanted you to spend a moment on is why you're in Calculus 1. So discuss very briefly why you're in Calculus 1. All right, then the next thing is complete this sentence, thinking about what you might get out of this class. It would be really fine if what I got from this class was, and complete that sentence and then reflect on somebody else's comments and discuss this for a little bit. Okay, and I'll just see if we're finishing up here. Give you a little bit more time. Okay, I'm going to stop you all now, and you can continue these conversations later. And, all right, there's one other thing that you're going to be doing in your groups. Is you're going to get an assignment today. In section 1.1, I'll be covering the material in 1.1. And the one thing you'll be doing is I'm going to tell you 2 problems. There'll be even numbered problems, so the answers are not in the textbook, that you'll need to get together with your group members to make sure that you agree on your answer for those 2 problems. There are 2 of the little more complex problems in the assignment. I am going to suggest, if one of you are familiar with Zoom, I think probably most people have done a Zoom session by now, that you zoom in so that you can see each other's faces, and then, you know, if you're getting different answers, work your way through it together to see if you can come to a consensus. And I'm going to be having you upload your homework, and eventually when I check that homework, those 2 problems specifically, I'll be checking for correctness, and but you'll have a chance to be working with your group mates on it, making sure that you are correct on those. I'm going to explain more details about how the class is going to work and how the grading is going to go and so on in a little bit. But before doing that, right now I want you to designate a group leader from each of your groups, so that the group leader today can get into action when I start my lecture. That, you know, the group leader can be interrupting me and, you know, giving me feedback. And actually there'll be times when I give a problem, and I'll very often introduce sections by giving a problem, and I'll have each group work on the problem for a while, and then I'll say, group 3, what's your answer? And the group leader will be the one who will be responding with, this is the answer that we came up with, and so on. So they'll be kind of the spokesman for the group. And if you have more than one person who wants to be the group leader, you can be rotating as time goes on, so that you can work out whatever you want, or if somebody gets tired of being the group leader or whatever. But for right now, though, designate a group leader for your group. I'll give you a couple minutes. Go ahead and talk that out amongst yourselves. Okay, and as soon as you have your group leader, the group leader from the text general channel, go ahead and get into the general channel and type GL for I'm the group leader. So hopefully I see GL written from 5 different people for groups 2 through 6. So Jay is the group leader, Josh, Kylie, 2 more group leaders. Josh, group 4, Riley, group 3.
Professor Shankin,
Yes.
this is Neil. For Group 2, we've come to agreement that I can be the leader.
Okay. Neil, you'll be leader. Great. And Christian. All right. So we're all accounted for with group leaders. All right. So we're going to take a break in about 10 minutes. I'll try to run. So our class runs from 11:30 to 1:45. So the rough format is going to be, we'll go 1 hour, 11:30 to 12:30. Take a 15-minute break, 12:30 to 12:45, and then the last hour. And if we need some adjustments to that, you can give me feedback, but we're going to start with that. So let's go for 10 more minutes here. I want to give a super brief overview of if you go into Canvas for this course. So here is this course in Canvas, and I'm going to put myself on student view. So you're going to see my screen. My screen now looks just the way a student screen would look. And announcements. So this one about getting notes for the class. We'll be trying this with OneNotes. And so read this carefully. If you don't have Microsoft Office, you can get it free as an SFCC student, and then you can have access to the notes from this. And let's go into the modules. Okay, you'll see in the modules, the very first one is going to be videos of classes. So after class today, I'll be putting the video of this class up. And so that can be especially handy if, like, you understood everything except there was one portion and you want to just rewatch the video on that. You can, if occasionally you miss the live feed for whatever reason, then you can watch the video. Okay, so then the Getting Started module. Here's information about getting the free Office 365 for being an SFCC student. You'll want to go into the assignment list. It tells you what all the assignments are. And it's a Microsoft Word document. So even these documents here, you'll need the Office to be able to read these, Microsoft Office Suite. And then then the schedule. So let me pull up the schedule real quick. And if you're going to print these things, you're probably familiar with this already, but if you print from this screen, it doesn't come out very good. If you click on the download first, download it, open it up, and then print it, you get a much better printout. So this tells you, this isn't the very latest. All right, so the summer schedule, I keep tampering with it, and I didn't upload the very latest one on this. So during our 15-minute break, which will be starting shortly, I will upload the most recent one of these, but it'll have all kinds of information in here about what we're doing when, and so, and then the textbook assignments. So module 1, so 1.1, if I click on this, it tells you the problem numbers of the textbook. And then after you do the problem numbers, you take a picture of it, and then you submit assignment, click on this button, and then you can upload, choose a file, and upload your assignment here. Now, there is the syllabus for this course. Let's go over here. Okay. Information about the text, the grading scale. All right. This part about the grading scale. I'm going to read this part. Approximately 1/3 of your grade comes from homework, 2/3 from testing. Example 1, someone with perfect scores in homework needs only a 71% average on exams and final exams to have an overall 80% average in the course. So it takes, barely getting a C all the way up to a B minus. Example 2, someone who does not have any homework assignments is missing 30%. Oh, I switched that. All right. I put a participation portion in the grades. I did that because of this online format. And this is the first time I've ever done a participation component of a grade. And I'm doing this because I really want to hold you accountable and with real clear expectations. When you're participating in this class, I want you to be totally focused and totally present here. And when I say, all right, here's this group activity, and then I call on the leader, and but I'm finding out that you've walked away from your computer and you were making a sandwich and you didn't participate in that, and your group leader, there was only 3 people in your group, but you were gone and you didn't participate at all, and this kind of stuff is happening. I'm not going to give you that 5% of the participation grade. I really want you totally present here, undistracted as much as you can create that environment. So we're back here. Is missing should be 25% of the grade. Thus, they would get nearly. Thus, if he or she got nearly perfect scores with a 98% average on exams and final, you'd only get a 68%, which is a D for the course. So it's really hard to do well in this course without keeping on top of the homework. Now that said, I then put this big exception. And I've had students in the past who have told me, I want my grade based not on homework at all, but just on the tests. And I can do that for students. I can't do it the other way around, because you have to be able to demonstrate that you've learned the problems and that you can do them independently of looking at an example and so on. But if you wanted your grade based solely on exams, and homework is not a component of your grade, just let me know in this very first week, and then I can set that up for you. The purpose of the homework schedule and structure is to give students the support that most students need. But if you're not one of those, if you're different and you'd like to have more flexibility with that, you just let me know. The purpose is, to have student success, and if that's not going to be what happens for you, or if you just need more flexibility. I've had other students tell me that, hey, I've got a job and I've got kids, and there's going to be, I'm going to need more flexibility in the deadlines and at certain times. If they let me know, then I can give them that flexibility. Be careful what you ask for. If you ask for that at the beginning of the semester, I'll give it to you. But you may be somebody who really needs deadlines, and so be careful if you're asking for loosening of a structure that might be very helpful for you. And this homework part, these are homework spot checks, are due the next day after assignment is given. So today I'm going to be assigning 1.1. Tomorrow is the spot check. And now if you were in there's a couple of you that were, a few of you I think, that were in a class of mine last semester. Spot checks are going to work differently this semester. At least 75% of the assignment must be completed for the spot check. Each assignment is worth 10 points, but 4 of those points, that's a big portion, 40%, comes from the spot check. At the end of the week, I wind up grading the homework. But before the homework is graded, you'll have plenty of time to rework the homework as needed. The Canvas due dates are the dates of the spot check. So if you look in Canvas on 1.1, it says the date that it's due is tomorrow. And it says the time that it's due is 11:30 tomorrow, which is the beginning of class tomorrow. So that's when you need to have uploaded the spot check, at least 75% of the problems done for 1.1. But suppose you had significant questions. You did at least 75%, but you're not sure that you did them all right, and a few of the ones at the end you're really not sure. Well, you have time then to ask questions, and it's not until the end of the week that I'm going to be checking these things. There's going to be a delay period in there so that you have time to get questions answered, go back and do the problems really thoroughly. In fact, that's the real way that math is learned. It's not learned in a one-shot deal. When you get complex material like we're going to have in calculus, you're just going to get stuck. It just happens. And you'll look at the problem and you say, well, geez, I have a real rough idea. I'm not sure, but then you go back and you look at your notes and so on, and then you try it, and then you wind up having to come back to these, and I'm giving you that structure so that you can come back and get all the problems pretty much totally correct, and that's what you want to be doing in this class.
I have a question.
Yes.
So what would be technically like the last day to turn it in? Would it be Sunday or would it be another day?
All right. So I'm going to have that. Let me address that after the break, because I'll go over the schedule with you. But the schedule needs to be updated, and I'll do that during this little break here. And that's what we'll start with then after a break. So right now it is 12:32. We'll start again in 15 minutes at 12:47. So
Mr. Shankin,
yes.
I have one more question.
Yes.
Can you upload the schedule and assignment list under a PDF so I can download it, because it's on Trio, which is a docx, and I can't print
I'll
it.
do both of those as well.
Thank you.
You bet. Okay, we'll start again in 15 minutes. Mom probably took her car, Claire. Let me mute this here. Okay. So either the other two cars, depending on how far you're going. If you're not going far, you can take the electric and take the other. Okay. So this has got this red circle.
Uh-huh.
What is that telling me?
You've got notifications in here. Because none of your other servers have dots on them, it means it's from this server. So inside of this server, inside of the groups.
Oh, it means I just haven't gone there yet.
Yeah.
Okay. So if I go to each of these groups, it's telling me those white dots.
Yeah.
Okay. This one I turned off notifications for, and that's why it's kind of grayed out.
Yeah.
Okay.
You'd have to scroll down to get rid of the notification, I believe. Oh, no. Inside of the chat. To the right. So go back to group 3. Move your cursor over to the right.
Okay.
And scroll down. Yeah. And once you reach the bottom.
Then it will tell me.
Yeah. No more notifications.
Okay. Only if I scroll down to the bottom.
Mm-hmm.
And, okay.
Because otherwise it'll send you to where the newest messages, the oldest messages you haven't seen yet.
So I should turn off notifications in all these groups.
Yeah.
Mute channel until I turn it back on.
Yeah.
Alright, so I'll do that with each one of those.
Yeah.
And then, what are these minuses, red minuses?
It's do not disturb. They can set different preferences.
And what does that mean for them when they do not disturb?
It's just saying they don't want people to talk to them. The green dot is that they're active. Online.
What's the difference between active and online?
You gotta remember that Discord is really for gaming.
Mm-hmm.
And so it's just kind of saying whether or not they're open to people talking to them while they play games.
So this doesn't really change anything, it's just people can look at it and say,
Yeah.
oh, don't send him a chat message.
Yeah.
Okay. And this doesn't say anything different than this.
Correct.
They both mean, does this mean he's on a cell phone? No.
It does.
It does.
It means mobile.
It means a mobile device, and this is probably on the computer.
Yeah.
And that's probably all it's saying.
Yeah.
Okay. And then, all right, now, there was somebody in here that had called average student, and I didn't know who they were. So I clicked on it, and they said, who are you? And then they sent a message back to me, but you see, when I clicked on them and said, who are you, it sent me into like an individual thing, and I had to click back on this to get back to here.
That's new.
But when they replied back to me, I couldn't get back to their reply. How do I get back to their reply?
Above the server you're on?
Yeah, this
Click
one?
on that, yeah.
Oh,
Home.
go to home.
And then you're going to move the screen, and direct messages are just below here.
Ah, you got to go to home, and then you can go.
Direct messages. Such as your average student. Here.
Okay. Okay, now this is from previous classes. Those are the new ones. Okay, gotcha. I got to go there to get to the direct messages.
Yeah.
Very helpful. Thank you. All right.
You got everything?
I think you've answered what I needed to get answered.
You're still muted, by the way.
Okay,
For once you
thanks.
start your class over again. I'll probably take the 4-hour.
Okay. All right, when are you leaving?
Not sure. We were supposed to meet up at 12, but Brad wasn't awake. Which is funny because he's the one who suggested it.
Acting like a 19-year-old, let's say.
Yeah. So, I'm not sure. I'll probably leave soon. Is there anything else you would want before we go?
No, I think I'm good.
I'll send you a text or call.
Oh, okay.
Yeah.
All right, we'll start up again now. And so I'm going to answer the question about when turning stuff in, when's the latest. So I uploaded a PDF of the latest, and if you click on download, and then you open it up, you would get something looking like this, our schedule. So we see that today 1.1 is assigned, and you're turning in nothing. And then on Tuesday, tomorrow, we're going to be covering 1.2. What you're going to turn in is the spot check of 1.1. At least 75% of 1.1 assignment needs to be uploaded before class begins, before 11:30. Okay. And then what that does is that puts you in a great position to be able to ask questions. The problems that you really didn't understand, you get to ask and get clarification on. Notice the next day we have a spot check of 1.2. Every day after a section is covered, you're getting that spot check of that section, meaning you have to upload and have at least 75% of the problems done. Now, if you're having troubles with the homework and you can't get to 75% done, you're going to have to use some other resources. You have to get online and consult with other students. Maybe some group members, when you're going over stuff, can get you, going on some issues, but you got to get up to 75%. There's also online tutoring with BrainFuse. The community college is paying for that, so that's free for you. There's instructions on that in the main Canvas page. Notice also, though, that there's this part, turn in. Now, when it says turn in, and generally these are at the end of the week. So, hold it, you've already turned in 1.1. Well, yeah, but this turn-in date is like the, kind of like, at this point, it's going to get graded. So you had up until this point to get everything correct. So what you uploaded for the first 75%, at least, doesn't have to be your final version. You can be, making changes and then uploading a portion or all of your homework over again, so that everything is correct when we get to here. So this is really the kind of like the date by which you want to have it, your final version of 1.1 and 1.2 in there. Notice the day before this, 1.4, is not in this list of what to have turned in, because you haven't had a chance to ask questions about it. You always have a chance for a spot check on something, and so what I assign on Wednesday, I don't have you formally have to have the final version of it in on Thursday. The next week, normally I would have the turn-in for the week be at the end of the week here, but we have an exam in the second week, and so I want you to have things turned in, the final form of all the stuff that is covered on this exam there. So that's what kind of interrupts the schedule. Generally speaking, the turn-in dates are Thursdays, except when there's an exam, then I have final version of those turn-ins at an exam. And you can see everything that we're doing, the test dates and all that stuff are all listed in here. I didn't see any, I tried to look for a calendar for the community college of, are there any days off over the summer? And there was none posted. Things are crazy in this COVID times here. And so I just made an executive decision here and decided that we're running every day. July 4th is on a weekend, and so that doesn't affect us, so we're going to have class each day all the way until semester. Any questions or comments on any of this? Right. And I think it was Bianca with the question. Did that answer your question, Bianca, about the turn-in date?
Yeah, that did. So, do we have to turn it in before 11:30 or before Thursday?
All right, Kylie, I'm putting out just feedback.
That's not me.
Or not Kylie.
Yeah, it's because Dominic.
Bianca. All right, so. Try your question again, Bianca, verbally.
Do we have to turn it in before 11:30 or before midnight?
Oh, the spot checks is before 11:30.
And what about the turn-in dates?
Pardon?
What about the turn-in dates?
I believe the turn-in dates, those are, yeah, the turn-in dates will be before midnight on those days. Yes, and they won't be in Canvas because the only date I put in there was a spot check date. Okay, but it'll be midnight of that same day.
I have a question.
Yes.
So our homework is section 1.1.
Yes.
So will that be pages in our book? It's going to be section 1.1 exercises, starting at page 9 and going on to page. Let me just double check here. 12, I believe.
Yes. Let's go and look at the assignment. Okay, mute your mic.
You got it. Okay.
So, the assignment list. Yeah, if I look in here, these are the specific problems in 1.1 that you're going to be doing. And it's at the end of the 1.1 section. So unfortunately the page numbers aren't on there. But if you have the textbook, you just page over to the end of the section to those specific problems. Does that answer your question? Neil?
Yes.
Okay. Any other questions? All right. So let's go into the section today of 1.1, review of functions. And while we're doing this, I'm going to ask the group leaders to be paying attention to what's going on in their group chats and interrupting me as needed. And you're not limited to the group leaders interrupting me. Anybody else can just pipe in at any point. If you text in something, I probably am going to miss it. So I really enjoy being interrupted verbally. So that's, instead of being a problem, that's a virtue here. Interrupting me, it might feel awkward, like, he's right in mid-sentence, he doesn't stop. And, I kind of continue on going, and you kind of have to just, stick something in right in the middle. But it'll be really helpful if you do that. But the group leaders, I need you to be active in helping me, giving me extra feedback here. All right, so.
Can I ask a question before you start on the explanation?
Yeah.
Okay, so on the list of problems that we're supposed to do, I do see that there are 2 even problems. So those are the ones we're going to be doing with our group?
Yes, the even numbered problems you're going to be doing on 1.1 are going to be 58 and 66. Okay? And then, so that's, you'll need to figure out when you're going to get together with your group on that. And when you're arranging the time to get together, make sure that you arrange a time where people have their homework done before you are getting together. Don't arrange it for immediately after class. People haven't done their homework yet. All right. Let's go to OneNote. Let's scroll down here. And the new section is 1.1 review of functions. And you see this little page right here? I added that page already. Tomorrow I'll be doing add a page, and I'll put the title for that section. You can scroll to any one of these pages. And so the first question we have is, what is a function? And what is a function? And I'm going to ask this question in this context. And I'm going to have each group discuss this. So if you have a situation that's the, let me go to draw. And I'll tell you what's the function. The situation is a post office. And here's going to be two quick tables. When you go to a post office, you have the weight and the price. And if the weight of a package is 1, 2, or 3, the price could be, let's say, $2, $4, or $4. All right. And this is a situation where the input is the weight, the output is the price, and the question is, before we get to what is a function, is this a function? All right, so go into your chat group, and I'll give you just a quick minute. Take a kind of a consensus, and then I'll be calling on 1 or 2 or 3 groups and just kind of getting feedback. Is this a function? And perhaps be able to explain why as well. All right, let me have you stop. Group 3, is this a function? What's your consensus?
Yes, it's a function
Why?
because there is only one input for every one output.
Okay, and if I was to turn this into something that is not a function, what would I have to do?
you would have to have two of the same numbers for an input for two different numbers for an output.
Okay. So let's create it. So this one, we'll say it is yes. And let's create a different one over here. The weight and the price. 1, 2, 2. And then if we had 2, 3, 4, this is what we call not a function. One input having two different outputs is a problem. We don't tend to find these situations, and this is what we'll say not a function. We find these not useful in math, sometimes things that are not functions are useful to us, but in general they're more useful if they are a function. And let's go to this, what is a function? And let me give you a definition. It's an input-output process where each input has exactly one output. And looking at this situation over here, if I have the input of 2, it only has one output, which is 4. Now the input of 3 also has the same output of 4, but that's not a problem with being a function. Each input has exactly one output. What is a problem is when one input has more than one output. Would this cause riots at the post office if I had the first table? Not at all. It would be a very, very common situation that different size packages, might have a whole range. Packages between, 3 ounces and 7 ounces all get charged the same price. But for this situation, you're going to get riots at the post office because one person gets charged $3, another person gets charged $4 for exactly the same weight of a package like this. What we want out of a function is predictability. If your cell phone were not a function, then when you hit the number 4, sometimes a 4 would come up, but sometimes a 5 or a 6 or something like this would come up. To be a function, every time you hit 4, a 4 comes up. That element of predictability makes it useful to us. Almost every man-made device, when we look at its core, to be a useful device, it is a function. If it didn't have that element of predictability, we wouldn't find it useful. Okay.
Professor Shanker?
Yes.
Shanker? Now, I always try to look at it visually, and so if you do that the vertical line test, so you can sort of see that with any x value you can't have more than just one. So if you have a line above and below for example, the x on any given x value, then that's not a function. I guess a good explanation would be a good example would be the y equals x squared. That's a function, because each x, and then if you check out x equals y squared, that's not, because it's there's an arm above the axis and below the x-axis.
Excellent, Neil. Thank you very much.
Sure.
Let's put a quick graph of this situation over here. When you have the input of 1, you have the output of 2. When you have the input of 2, you have the output of 4. When you have the input of 3, you have the output of 4 again. Now this function, this right here passes the vertical line test. Any vertical line will go through this graph only once. But over here, you have the input of 1, the output of 2, the input of 2, the output of 3, the input of 2, the output of 4. It fails the vertical line test. The vertical line right through here is going to intersect the graph more than once. And in order to be a function, every single function will pass a vertical line test. A vertical line test is if any vertical line, even just one, hits more than one time on the graph, then it is not a function. And that means that one input has more than one output. In a more general sense, for functions, as Neil was describing, you have those parabolas. An upward parabola is a function, but a sideways parabola is not a function, fails the vertical line test. All right, so you see where we're going in 1.1, review of functions. This is nothing new. We're just reviewing, and we're only going to be doing 3 sections of review. 1.1, 1.2, and then 1.4. And after that, everything is going to be new in this course. Every single day you're going to get a calculus concept that's totally new to you with very new types of problems. So bear with me for just these first 3 sections. These first 3 sections, although it's a review, it's extremely important review. I had a student in my calculus. Which calculus was it? I think it was calculus 2. He was an older student. I had him years ago. And I remember one day he got so upset. No, it was calculus 3. He got so upset one day and he said, "God damn it, why didn't they tell me this stuff was going to be useful when they taught it to me in algebra?" And because it wasn't the calculus that he was having the difficulty with, it was the algebra concepts that he was having, were coming up. And so the intention of all this algebra training that you've been having so far is we want you to get so good at algebra that it doesn't use up so much of your brain power, so that what's going to be happening in this calculus class is you're going to be doing some intense algebra, but we want you to have leftover brain power to think about, but also this is going on, and it represents this. And so we want you to kind of be able to do the algebra kind of without so much thinking, so you have extra power for analysis going on. So this, we're just getting this fundamental concept here of functions, and getting us started. Let's do another question, and that's, let's talk about domain. It's a set of all inputs, all possible inputs of a function. Now, if it doesn't pass the vertical line test, and it's not a function, we have a name for it. It's called a relation then. A relation because it's some kind of relationship between the input and the output. But if it passes the vertical line test, then it's a function, and most of the time we're dealing with functions. But we could technically say a function or relation. Relation is some relationship where it doesn't pass the vertical line test, while the range is the set of all outputs possible of a function or a relation. All right. And by the way, you'll have access to all these notes through the OneNote, through that one link, but you have to have Microsoft Office installed. Now, let's go with a couple quick problems on hang on just a second. Problem 1, f of x equals and we'll stop that here, and I'm going to write this in for speed's sake. Is the square root of x. And problem 2, f of x is equal to 7 minus 3x over x squared minus 16. So, what I want is not the domain and range for each one of these, it's just the domain for each one. And the domain for each of these. So, let me give you a minute to ponder both of these, and then I'll go over these answers. So, you just work individually. Write in your best estimate for the domain for both. Alright, so the first one, the domain, set of all possible inputs is the x greater than or equal to 0. You cannot take the square root of negative numbers. And for this one, if I visualize this, this, I would see that x can't equal negative 4, x can't equal 4, because 0 on the top of a fraction is no problem, but 0 in the denominator of a fraction makes the fraction illegal, and we have to make sure that that doesn't happen. And so we say these two things are not allowed. Sometimes the question about range is an easy question. On this one, range is f of x is greater than or equal to 0. Over here. But on this one, the range, we often don't ask that question over here because it's kind of too difficult. If the range is kind of obvious, we might ask it, but very often we're really mostly interested in how can you make sure that you don't get illegal values. All right. I want to cover one thing that's really basic, but just to make sure that you have it. 8 divided by 2 is 4. How do I check my answer? well, I take 2 times 4 and I get 8. How do I imagine what this problem means? When we're in elementary school, we're taught 8 cookies divided equally among 2 children. There's 4 cookies for each child. But that fails to work when we're dividing by things like, if I had 4 divided by 0.01. So a better, more generalized way of looking at a situation like this is how many times bigger is the numerator than the denominator? Or how many times do I have to add the denominator to itself to get that number? And this one is 1/100th on the bottom. I have to add it to itself 100 times just to get 1, and then I multiply that by 4, so this would be why this is so huge, it's 400. That number is 400 times bigger than that number. All right. So we can see a glimpse into why 0 divided by 5 is not a problem. This times this is equal to this. It checks just like this times this is equal to this. And it also is how many times, 0 divided into 5 equal pieces, each piece is size 0. But when you have 7 divided by 0, and you try to set it equal to 0, this times this does not equal that. And also, how many times do you add this to itself? To get to this, you add it to itself an infinite number of times, you're still stuck at 0. It's so impossible that we have to say that this is just not allowed. And so we have to exclude that as part of the domain here. And we have composite functions. So functions, and in composition, I'm going to assume that you have some basics of this remembered, and I'm going to ask a little more complex question. And the complex question is this. So if f of x is equal to 3x minus 2, well, find 2 functions h of x and g of x. Find g of x and h of x. So that f of x is equal to g of h of x. All right. So this problem, I want you to go into your group and see if together you can piece this out. Somebody might have a hint of how to get started, and then I'm going to ask a group or two where you're going. So I'm going to give you a minute with this problem.
Professor Shankin?
Yes.
I'm having trouble. I get a message that says player popped out, and I just have a blank screen there for your image.
Anybody else having that problem? No?
Yeah, I guess I may be the only one. I asked my group.
Yeah.
But it's like I click on I double click on your thing and it just says player popped out and it's just black.
Okay. So what I want you to do then is get out of the screen sharing and then do it again and get back in.
Oh, okay.
And periodically people have issues every now and then too. Things just
Yeah.
mess up,
Okay.
and that'll probably be the most common resolution.
So just log out, huh? And just
Of the
probably.
screen sharing.
Oh, okay.
You can still stay in Discord, but just like no longer share my screen, and then
Oh, okay.
Initiate another of joining my screen.
Yeah. Sounds good.
Okay. Let me have you stop. Group 4. Any ideas here?
All right. So my thought process in this is h of x is equal to 3x, and g of x equals x plus or x minus 2.
So h of x, let's try that. H of x is equal to, what did you said? X minus 2?
3x.
Oh, just 3x.
Yeah.
And then g of x is x minus 2. Well, let's check that out and see if that works. And let me insert some more space here. Okay. So up here. If we take g of h of x, it's the h of x is 3x, so we replace it with 3x, and the g of anything means it's that anything minus 2, and that will work. All right, so in order, what we had to do there was, and this is part that's a bit counterintuitive, is we think of the f of x as these two parts, multiplying by 3 and subtracting 2. We said, the h of x happened first, it's the innermost parentheses, and that's the same thing we'd have to do if I said, find f of 10. First thing you have to do is multiply by 3 and then subtract 2. So we had to multiply by 3 as the inner function, so that one was done first. And then it would be 30 minus 2 would give me the 28, would give me something like this. All right, so my next question then is this unique? Or is there another possible answer to this? Could you come up with two different functions, h of x and g of x, so that when you put them together in composition, you get 3x minus 2. I'm going to give you 30 seconds very quickly to discuss that. What do you think? Is this unique? Is there only one answer? Or are there more? Group 5, what do you think? One answer?
I think it's not unique.
I think it's not unique.
Yes.
So there is another possible answer. Okay. And turns out you are totally correct. So another possible answer might be h of x equals 3x minus, or we'll say plus 1. And then g of x. Now, we're going to do something to this. If we just keep it and then subtract 3 from it, that would give us, in the end, the same answer as over here. And in fact, you can always, as well, keep the h of x being the inner function being the whole function. And then the outer function could just be g of x equals x. It just stays itself. And there's an infinite number of ways to break it up. But there is only one, usually, that is kind of natural to the situation. What's natural to the situation is to break it up into multiplying by 3 and subtracting 2. And so that's usually the answer that we want. And some of the homework problems are going to be like this. They're going to say, all right, here's a complex function, find 2 other functions. Or here's an inner function, find the outer function that will produce this other more complex function. All right, let's look at this one real quick. To state the domain and the range of this. The domain from a graph is some kind of limit on the x. And we could state that the domain is, now how far left to how far right does this graph go? It goes from 1, it includes the endpoint, so I put the equal sign, and it goes to 4, like this. The other way to state that is bracket 1, comma, 4, parentheses. And the range would be from how low to how high does this graph go. And more common, instead of putting it in the inequalities, is to put it in interval notation. And we would say it goes, the minimum height is 1 to a maximum height of, now, what's the highest it ever gets to? 5. Does it actually get to 5? It appears to actually get to 5. So I put it in a bracket like this. So there would be the domain and the range of something like this. Something that's going to be new is what's called a difference quotient. And so a difference quotient is there's 2 different forms of a difference quotient. And this idea is going to show up very soon in calculus portion when we get to the new material. And the goal here is we want you to get used to some of the algebra that's going to happen early, so that when we do this with the context of calculus, that you can not be so focused on the algebra, and you can handle the algebra really easily. So, what is a difference quotient? A difference quotient is a quotient, so it's a fraction, and it looks like this. It has 2 different possible formats. The most common one is this: f of x plus h minus f of x over x minus h. No, over just h. Let me get my eraser. All right. So that's what we call a difference quotient. And we could find the difference quotient for a bunch of different functions. If f of x is equal to 2x plus 3, we might be asked to find the difference quotient for that. Now, if I was a student in this class, at this point I'd be a little bit lost. I'd say, well, what in the world does this expression mean? And how can we find it for a particular function? And I tended in math to do well when I could really understand everything. But when something was presented kind of out of context and just kind of like say, just imitate this, I tended to really struggle with that stuff. So I want to describe what's going on here. Is I'm doing something that's kind of unusual for me, which is I'm not going to really describe what this means at this point, because that's not the intention here. The intention here is to just get you used to how to do the algebra on this. So,
Professor Shankin,
yes.
pardon my interrupt, but would this be the same type of difference quotient as the slope, for example, rise over the run? Or is this, the delta, like delta y over delta x? Or is this some other difference quotient?
We're going to wind up seeing later on that this is the rise over the run for an instantaneous function. That is correct. But for right now, we're not going to emphasize that. Right now, I'm just going to emphasize how to do the algebraic manipulation.
Great, thanks.
How do I find that when the function is this? All right. So how I do it is right here. The main thing to realize is that this expression right here has really three parts. There's the part of f of x plus h. There's a part of f of x. And then there's putting them all together. If I do f of x plus h for this particular function, now what f of x equals 2x plus 3 really means is f of anything is 2 times that thing plus 3. So I'm going to substitute x plus h in every time I see the x. What f of x means, well, it just means 2x plus 3. Now, for the whole thing, I can write out the difference quotient is equal to what I got for f of x plus h. Oops. 2x plus 2h plus 3 all divided. Now that was this part right here, minus f of x was 2x plus 3 and then it's divided by h. Now, when I further work on this, I'm going to have the 2x and minus 2x cancel each other out. The 3 and this is going to be a minus 3, they'll cancel each other out. All I'm going to be left with is 2h over h. And the h's divide out, and I'm left with 2. So the difference quotient for this function turns out to be 2. Every single function, we can get a difference quotient for it. And I just plug it in to this format to find the difference quotient. And again, this is going to have very little meaning to you. We'll eventually find out that this is really important. It has to do with slopes and instantaneous slopes. But for right now, it's just an algebraic manipulation. I want you to get used to make things easier in the future. And when we do it with a more complex function, number 2. Suppose my function f of x is x squared minus 1. Then my difference quotient is going to be, well, remember the different parts of the difference quotient. The difference quotient itself is f of x plus h minus f of x over h. So the f of x plus h, I'm going to write that out here. This is going to be x plus h squared minus 1, which, when I FOIL that out, so it would be a big mistake to call that x squared plus h squared. Instead, I have to FOIL it out. And when I FOIL it out, I'm going to get x squared plus 2hx, because you're going to get one of those from this and another one from the inner, plus h squared minus 1. Alright, so that's the only part, if I was trying to be efficient, that I would really write out beforehand. And then I would go to my difference quotient like this. F x plus h minus f of x all divided by h. Now, we're going to finish this up. I'm going to substitute for f of x plus h, I'm going to put this whole thing right in there. I'm going to put it in brackets. Minus, now f of x, now a very common student mistake is to not put parentheses around this, but all of f of x is subtracted, so I've got to have parentheses around it, all divided by h. And then I can see that this and this will cancel. This minus 1 and this plus 1 will cancel. And I'll get 2hx plus h squared divided by h. Alright, at this point, I'm going to wonder, can I reduce this? Can I just cancel this h with this h right over here? That would be similar to like 8 plus 3 divided by 4. Can I cancel this 4 with this 8? The answer is no. But if this was something that this 4 would have to divide into both of these. If it was 8 times 3 divided by 4, then I could cancel these. What I'm going to do is I'm going to say what's common to both of these. H. H is common. What's left over is 2x plus h divided by h. Now, what I've done is this first expression here, this was really like this. Two things added together I can't cancel. This expression is really like this. This thing times this thing over this. Here the 4's could cancel, here the h's can cancel. So now, and that's what factoring does for us, turns an addition problem into a multiplication problem. So then I take this h and cancel it with this one, and I get 2x plus h. So what we find out when we do a difference quotient, just the algebraic process, when you're figuring out this, for any function, the h's at the bottom will always be able to cancel out. If your h's aren't canceling out in your homework, then something is not right. You need them to get canceled out. You'll get an expression without the h. We'll also find out later on that this fancy expression for a difference quotient could also have been written like this. If you had f of x plus, f of x minus f of a over x minus a. If you have this expression, that's going to be the same in the end as this other one. Difference quotient. That's the same as this one. Those two expressions wind up having equivalent, and you'll see that when you wind up doing the homework. It'll have you actually do a difference quotient like this, and it'll tell you what the a is over there. And so we have run out of time. So the homework is 1.1. Just the problems that you see in the assignment list. You need to upload at least 75% of that before class tomorrow for the spot checks. And again, if you have a schedule or situation like, I just won't be able to do these spot checks and I'll have to be doing a lot of my homework at the end of the week. If you've got, really strange situations like this and you just talk to me this first week, we'll work out something else, whatever that works for you. What I've found though is that for most students, keeping up to date like this is like they tell me afterwards, oh my gosh, I have learned so much more when I'm keeping up to date day by day than when I was procrastinating and doing a whole week's homework in one night and all this kind of stuff. So that's why I put this schedule out there, but if that doesn't work for you, you just let me know, we'll make an alternate plan. All right. Also, you need to get together with your group members and check 2 problems, the 2 even-numbered problems on the homework, which are 58 and 66. And there's some more stuff on the syllabus that I want to go over. We'll do that next time. But we'll stop here for today. Any questions? All right, I'll see you all tomorrow.
Thank you.
You're very welcome. Thanks for the reminder to stop the recording.